Hi everybody. Today we're going to be looking at ACT Review Packet number 2, Geometry. This starts off with 4 problems that are called Perform, and then there's 40 on your own questions. When I was going through this packet, I noticed that there were a number of problems that were formula related. A lot of formulas in this packet. And sometimes they gave you the formula, for example, the law of sines problem at the end, but in many cases they didn't give you the formula, and you were expected to know those. So I thought it might be helpful for us to do a quick review of certainly not all of some of the formulas they expect you to remember. So first of all, midpoint. If I'm trying to find the midpoint between 2 points, x1, y1, x2, y2, the midpoint is the average. So I want to know the average of these points. Well, I'm going to take those x values, add them together, and divide by 2. I'm going to take those y values and add them together and divide by 2. And this will give me the ordered pair that represents the midpoint on that segment. Now, likewise, dealing with a segment, I've noticed that they often ask about the distance formula. And remember, the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And remember, this is coming directly from the Pythagorean theorem. We're doing a squared plus b squared equals c squared. Our distance, c squared, is d. And this is the difference between y2 and y1. And this is the distance from this x value, x2 to x1. So this thing squared plus this thing squared equals this thing squared. And since I don't want distance squared, I just want distance, I have to take the square root of both sides. So we're going to need the midpoint formula and the distance formula here for sure. There are other formulas we need to know. I also noticed that we need to know and be comfortable with our 30, 60, 90 right triangle, side ratios. So in a 30, 60, 90, if the short leg is x, the hypotenuse is 2x, and we could always use the Pythagorean theorem to find the long leg, but it's faster to realize that the long leg is the short leg times root 3. So short leg times root 3. Those are the ratio of sides in a 30, 60, 90. In a 45, 45, 90, where the side lengths are the same because the angles are the same, these would be x, and again I could use the Pythagorean theorem to find the length of the hypotenuse, or it's much faster if I just happen to know that the ratio is x, x, x root 2. Root 2 times the side length gives me the hypotenuse. But again, if you don't remember that, you can always use the Pythagorean theorem. A squared plus b squared equals hypotenuse squared. 2x squared is hypotenuse squared, and then we take the square root of both sides to get h equals square root of 2 times square root of x squared, so h equals root 2 times x. Okay. There will be many others that come up as we go, but I definitely wanted to look at those 4 right away because they seem to come up quite a bit. In fact, in problem number 23, in the figure below, which point does XZ intersect its perpendicular bisector? Well, I know a perpendicular bisector has to bisect the line and therefore pass through the midpoint of that line. So I've got this line XZ, with endpoints located at 4, 8 and 10, 4. I counted those based on the scale they gave me on the graph. And I want to find the midpoint between these two endpoints. So 4 plus 10 divided by 2, 8 plus 4 divided by 2. 14 over 2, 12 over 2, which is 7, 6. So my midpoint is located at 7, 6, and that corresponds with choice D. Let's take a look at 24. 24 says square QRST is inscribed inside of square ABCD. Now, it's important to recognize, and they don't explicitly tell us this, they really needed to, that Q, R, S, and T are all midpoints of their side lengths. So this is equal to this, and this is equal to this, and this is equal to this, and this is equal to this. And when we see that, we can recognize that we have a 45, 45, 90 right triangle here, and another 45, 45, 90 right triangle here. Okay, we're told that SR is 5. Well, the hypotenuse is 5. And what was it that I just said about in a 45, 45, 90? This is x, and this was x root 2. So I know that the hypotenuse is the side length times root 2. Well, here the hypotenuse is 5, and so that must equal the side length times root 2. If I divide both sides by root 2, I get the side length is 5 over root 2. And if I pull out my calculator and evaluate 5 divided by, oh no, we want the area of this triangle. Okay, so let's take it a little further. We know that this triangle has 5 over root 2 and 5 over root 2 as its base and height. And we know the formula for area of a triangle is 1/2 base times height. So I want 1/2 5 over root 2 times 5 over root 2. That gives me 25 on top. Root 2 times root 2 is 2, and 2 times 2 is 4. So that's 6 1/4, or choice F for number 24. Let's take a look at 25. 25 says the opening of a perfectly circular sewer has a circumference of 8 pi. Well, I remember the formula for circumference is 2 pi r. And if you didn't remember, please notice they didn't provide us with that formula here, so we would have a tough time with this problem. It's really worth your time to take a little time to review your basic geometry formulas. For example, circumference of a circle. Area of a circle, remember, is pi r squared. Well, in this problem, we know that the circumference, or 2 pi r, is equal to 8 pi. If I divide both sides by 2 pi, I can get that the radius is 4. Okay, so I know that the radius is 4. Now the tunnel has a volume of 2,048 pi cubic feet. Well, the tunnel, because it has these circular openings, must be a cylinder. And the formula for volume of a cylinder is pi r squared h. We just figured out that the radius of this opening was 4 feet. What about the height? Well, the height of the cylinder is this. This is the height of the cylinder, also known as the length of the tunnel. Well, that's what we're trying to find. How long is this tunnel? So let's plug in what we know. We know that the volume is 2048 pi, and we know the formula for volume of a cylinder is pi r squared, 4 squared times length, or 2048 pi equals 16 pi times L. If I divide both sides by 16 pi, 2048 divided by 16 gives me 128. So I get choice D for number 25. Okay, how about 26? With problem number 26, they ask us to find the relationship between H and B using theta. Okay. Well, I know, for example, that the tangent of theta would be H over B, because tangent is opposite over hypotenuse. But I notice none of my choices involve tangent. They all involve cosine. And in order to use cosine, I need adjacent over hypotenuse. And the picture has the adjacent side labeled as B, but it doesn't have the hypotenuse. So I'm going to have to find the hypotenuse. H. Oh. Yeah, not H. This is H, this is B, and I don't know what that is. So B squared plus H squared equals question mark squared. And I want to know what question mark is, so I'm going to take the square root of both sides. Question mark is therefore B squared plus H squared under a square root. This is not equal to B plus H. Don't you do that. So here we have B squared plus H squared. And if this is theta, cosine, remember, is adjacent over hypotenuse. Cosine of theta is adjacent over hypotenuse. Okay, so those were the perform questions. Let's take a look at the on your own questions. Number 1, what's the slope of the line shown in the coordinate plane? Well, we know the formula for slope, rise over run, is y2 minus y1 over x2 minus x1. They've given me some ordered pairs, 6, 0, and 0, 3. So I'll do 0 minus 3 over 6 minus 0. I'll get negative 3 over 6, or negative 1/2. This corresponds with choice C. Choice C for number 1. Number 2. So when I looked at this question, I started by saying, well, this is the point 0, negative 3. And then I counted the slope off the graph, and I noticed that I went up 1 and over 4. So I went up 1 and over 4. 4, negative 2 was another point on the graph. Okay, so with that in mind, I said, well, what information do I need to write the equation of a line? Remember, y equals mx plus b. B is the y-intercept. Good, I've got that. I know that b equals negative 3. The other thing I need is the slope. So how do I find the slope? Well, I can use these two ordered pairs and the slope formula to find the slope. Negative 2 minus a negative 3 over 4 minus 0. And I get 1 over 4. The slope is 1/4. And so I'm looking at y equals 1/4 x minus 3. But I notice that all the choices are given in standard form, not slope-intercept form. So I'm going to move this x stuff to the right-hand side. So I'll have negative 1/4 x plus y equals negative 3. And now I notice that there are no fractions with any of my answer choices for coefficients. So I'm going to multiply everything by negative 4. Why? Well, if I multiply by negative 4 here, negative 4 times negative 1/4, these cancel, giving me positive x. negative 4, and negative 4. Negative 4y, and negative times negative is positive 12. So there's the equation of the line. But now I feel like I need to consider the inequality symbol. So if I test a point like 0, 0, 0, 0 should not be a solution. So if I plug a 0 in here and a 0 in here, I get 0 and 12. Well, if I made the symbol go this way, that would be true. And I want 0, 0 not to be a solution. So I want the inequality symbol facing the other direction. So x minus 4y is greater than 12. Okay, so if I test that by plugging in a point here, like 0, negative 4, that should be a solution. That should be correct. 0 minus 4 times negative 4 is greater than 12. Well, it looks like 16 is greater than 12, and that is true. So I chose correctly with the inequality symbol. And this corresponds with choice F. Choice F. Okay, there's number 2. Number 3. Let's take a look at 3. Based on the graph, how much does 1 linear foot of this particular wood cost? Well, when I think about the cost of a foot, that's dollars per foot, I'm thinking about a rate of change or a slope. Now, I notice that I've got some ordered pairs that I can read off this graph. One is 0, 150, and I see another one at 5, 225. And so I'm going to use the slope formula here. 225 minus 150 over 5 minus 0. That's 75 over 5, or 15 over 1. This is dollars per foot. What's the cost of 1 foot? $15. And that corresponds with choice C. Okay, number 4. What's the length of the line segment with these given endpoints? Well, there's our distance formula that we talked about before. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, all under the square root. So if I plug stuff in, I'm going to have 3 minus a minus 2 squared plus negative 6 minus 6 squared. Well, that looks like 5 squared plus negative 12 squared, or 25 plus 144, which is the square root of 169, or 13. And that corresponds with choice K. K for number 4. Let's take a look at number 5. 5 says, given the point A is located at negative 3, negative 8, and the midpoint of the segment is located at 1, negative 5, what are the coordinates of point B? Well, I see that the x values to get from one end to the middle go up by 4. So to go from the middle to the other end, I want to go up by another 4. 1 plus another 4 will bring me to 5. And likewise, I notice the y values go from negative 8 to negative 5. That means they go up by 3. And so to go from the middle to the other end, the y values need to go up by another positive 3. Negative 5 plus 3 is negative 2. So 5, negative 2 corresponds with choice A. How about number 6? 6 says, what is the area of the shaded sector for the circle shown below? Well, I know the formula for area of a circle is pi r squared, but the sector is some part of the whole area. And which part of the whole area? Well, 60 degrees out of 360 degrees. Our number of degrees over the total degrees possible. times pi, and the radius here, well, I see when I count the boxes, that the center of the circle is located at -1, 0, and so the radius must be 1, 2, 3, 4, 5, 6. So this would be 6 squared. Okay, so that's 1/6 times 36 pi. The 6 is here, the 6 and the 36 can do some canceling, and I end up with 6 pi, which is choice G for number 6. How about number 7? Okay, number 7, we see here this line that we want to reflect across, and we've been given some ordered pairs, and I notice, for example, that A is located at 2, 2. Now, when I reflect this point across that line, we're not moving left or right at all. We're just taking this distance and flipping it up here. Well, if this is the line y equals 3, then this is the y value of 2. This distance is 1. So this distance must also be 1. The x value will be the same, but how far away am I? Well, I was at 2, I added 1 to get to 3, I add another 1 to get to 4. So that's where A would be when I reflected it, but they asked me about B. Well, B is down here at 4, -1. How far is it from -1 up to the line of 3? 3 minus a -1 is 4. That means I'm going to go 4 above that line to get to the y value of my new B, my reflected B. The x value stays the same. I'm just changing the y's here by doing this reflection. And so I'll have the ordered pair 4, 7 as my answer, and that corresponds with choice D. D for number 7. 8. Which of the following equations best describes the set of all points that are the same distance of 5 units from a point -3, 4? Well, this is almost exactly the definition of a circle. The definition of a circle is the set of all points that are the same distance from a given center point. We remember, I hope, that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h, k represents the center. So here we're told that the center from that given point is -3, 4. So I'll have x minus a -3 plus y minus 4. And how far are they? They are 5. So we end up with x plus 3 squared plus y minus 4 squared equals 25. And that's choice J. Problem 9. 9 gives us this picture with a lot of congruent segments. We know that these are all congruent, but we also know that this is congruent. Well, since all the sides are equal, then all the angles must be equal, and therefore this is 60 degrees. And again, since all the sides are equal, we know that all the angles must be equal, so this is 60 degrees. And this problem says, what happens if I do B minus C? 60 degrees minus 60 degrees gives me 0 degrees. So choice C is my answer for number 9. Number 10. The longer leg of a right triangle is twice the shorter leg. So here's the shorter leg, and the longer leg is twice as long. If the lengths of both legs are whole numbers, which of the following could be the hypotenuse? Well, I know I can use the Pythagorean theorem here to help me find the hypotenuse. Let's do that. A squared plus b squared equals c squared. So I get x squared plus 4x squared equals h squared. Or 1x squared plus 4x squared is 5x squared equals h squared. Now, they ask me which of the following could be the length of the hypotenuse. And notice that what we're going to do next here is take the square root of both sides to get hypotenuse. Notice the number under the radical has to be a multiple of 5. 5, in fact, times a number being squared. So when we look at the choices that they've given us over here, which of these is a multiple of 5? In fact, 5 times the number squared. Well, this one is. This is 5 times the number 3 squared. So we know the side length is 3, but we don't care about the side length. We just want to know the hypotenuse. And the hypotenuse must be f, or could be f, but could not be any of those others. Now, you might be saying, well, couldn't the side lengths be, couldn't square root of 48 work as well, and we just divide 48 by 5? Yeah, except that the problem says that both the legs are whole numbers. And if we divided by 5, we wouldn't get a whole number side length anymore. So, F is my choice for 10. Let's take a look at 11. 11. A ramp, ooh, and stairs. There's a lot going on in this picture. Okay, so they tell me that this distance is 20 inches, and this distance is 8 feet. Well, I know that 1 foot is 12 inches, so 8 feet would be 8 times 12, or 96 inches. So this is 96 inches plus 20 inches, so this whole side is 116 inches. Okay, they ask me what's the length of the ramp. So I need to know the length of the ramp, and the length of the ramp would be this. Now, they also tell me that this angle here is 30 degrees. And I remember that the cosine is adjacent over hypotenuse. And so if I multiply both sides by x, I get x cosine 30 equals 116. Now, cosine 30, if we're comfortable with our unit circle, we know that the cosine of 30 is the square root of 3 over 2. And so I could write root 3 over 2 equals 116, and then divide both sides by this to get x equals 116 over root 3 over 2, or 232 over root 3. That's not one of my choices. In fact, all my choices are whole numbers, and the question says which is about how long. So they just want an approximation here. And I could just use my calculator at this point and say, well, the ramp is going to be 116 divided by the cosine of 30. My calculator should give me an answer approximately 134 feet. Now, one of the things I do know is that the hypotenuse has to be the longest side. And if the hypotenuse is the longest side, then I know that this has to be longer than 116. And so I am easily able to rule out choices A, B, and C for that. And so I'm just narrowing down between D and E. And I see my choice here is E. Okay, 112. 112. Oh, I'm sorry, number 12. Number 12 gives me an equilateral triangle on the outside. Is it? Oh, no, it's not. Yes, it is. No, it's not. I thought it was originally, but it's not. I do have this square inside. And I know that the area of the square is 12. And I know area is side squared. So if I take the square root of both sides, I get that the side is square root of 12, or 2 times 2 times 3, 2 root 3. So this is 2 root 3, and this is 2 root 3. Now, let's think about what's going on here. Up here, I know that well, I'm trying to think about what I know and how I know it. I know that this is 90, so I know that this is 90. And this is 2 root 3. Oh, it is inscribed in an equilateral triangle. This is an equilateral triangle. And so I know that these angles are 60s. Okay, and because this is 60 and these are congruent, I know that that this is a little equilateral triangle here. So this is 2 root 3, and this is 2 root 3. Now down here, these triangles, in fact, are not the same as that triangle. We know that this is 2 root 3, this is 60, this is 30, this is 90. And I'm looking for how long is that, right? That's this piece here. Well, I know that in a 30, 60, 90 right triangle, we said before that if the short leg is x, this would be x root 3, and this would be 2x. Well, in this problem, we're told that this side is in fact 2 root 3. So x equals 2. And the hypotenuse is the short leg times 2, so 2 times 2, or 4. So I know this is 4, and this is 2, and this is 2 root 3, and this is 2, and this is 4. Wow, so what's the perimeter of that big outside triangle? It's a 2 root 3 plus 4, and another 2 root 3 plus 4, so I have 2 of those. And the bottom down here isn't the same, it's 2 plus 2, or 4 plus 2 root 3. Oh, that is the same. How funny. I wasn't expecting that to be the same. So I have 3 of those 2 root 3 plus 4s. 3 times 2 root 3 plus 4. And if I distribute, I end up with 6 root 3 plus 12, which is choice K. K for number 12. Okay. 13. Says Mark has a rectangular flower bed twice as long as it is wide. Okay, so that's wide, and the length is twice as wide as it is long. I'm sorry, twice as long as it is wide. The area of the vegetable garden is twice as long and twice as wide as the flower bed. So vegetable garden, twice as wide and twice as long. So we get 4W for that side and 2W for this side. And what about the area is how many times as large as the area of the flower bed? Okay, well, I know that, I know the area here is just length times width, but the area here is 2L times 2W. And we end up with 4 length times width. How much bigger is the vegetable garden compared to the flower garden? Well, the flower garden's area is length times width, and the vegetable garden's area is 4 times length times width. So I say 4 times larger, which corresponds to choice C. Okay. 14. A circle with a radius of 5 is inscribed in a square. Inscribed in means drawn inside of. And drawn inside of so that we are tangent to the sides. Not only are we tangent, but these will now be midpoints. Okay, we know that the radius of the circle is 5. This is also a radius. So what's the side length of the square going to be? Well, this 5 plus this 5 gives me a side length of 10. And what about the... Oh, and so it says, what's the difference in the area of the square and the area of the circle? Well, the square has side lengths of 10, so the area of the square is 10 squared, or 100. And the area of the circle is pi times the radius squared, or 25 pi. And the difference between these two is 100 minus 25 pi, which corresponds to choice J. Choice J. Okay, what about number 15? In the figure shown below, we know that FG has a length of a length of 12. Now remember that this segment from the radius is bisecting that chord, so if this whole chord is 12, this is 6 and this is 6. We know that the area of this triangle is 24. This is OH here. So if I use that area formula, area equals 1/2 base times height, I know that the area in this problem is 24. The base is 6 times the height of OH. Well, these cancel, giving me 3. And if I divide both sides by 3, I get that OH equals 8. So I know that this is 8. Clearly not drawn to scale. Now, what do they ask me? They ask me in this problem, what is the area of the circle? Well, in order to find the area of the circle, I need the radius, and that's this side here. Now, it would be really great if I recognized that 6, 8, 10 was a Pythagorean triple, but if I don't, I can always do 6 squared plus 8 squared equals radius squared. And I'll get 100 is radius squared, and so radius, when I take the square root of both sides, is 10. The area of the circle is pi r squared, so pi times 10 squared, or 100 pi. And 100 pi corresponds to choice E. Choice E for number 15. 16. Let's take a look at 16. The circle is not shown, so I think I'm going to draw one. Here's circle O, not shown, with a radius of 5 and an angle AOB. Okay, so AOB is 45 degrees. What is the length of arc AB? So they want to know the length of this arc. Now I remember the arc length formula from trig class is S equals R theta, and theta has to be in radians. But if I don't know what radians are yet, then the way I think about this problem is to say, okay, I want some part of the whole circumference. Circumference is 2 pi r, and since our radius is 10, we would have 2 pi times 5, or 10 pi is the circumference. Sorry, radius is 5, circumference is 10 pi. What part of the whole way around do we want? Well, we want 45 degrees over 360 degrees. Some part of the whole way around times 10 pi. And I end up then with 5 pi over 4, which I could get by using s equals r theta as long as I converted 45 degrees into radians. 45 degrees is pi over 4 radians, so radius times pi over 4 gives me 5 pi over 4. So 5 pi over 4 is my answer here, and that corresponds with H for number 16. Number 17. Vertical cross-section of a bulldozer shovel. Okay, is used for moving large volumes of sand. Shovel is 40 inches wide, not shown. 40 inches wide. Okay, so this shape that they're giving me is only part of what I'm seeing. We're really looking at a shape like this. Okay, so the volume of this container is going to be the area of the base times the length. That's how I find volume of a prism. And that 40 inches that they didn't label is going to be important because that's going to be times the area of this base. Okay, let's take a look at the area of this base now. It appears to be a trapezoid and a rectangle. I notice that this is 15 and this is 25, so this would be 375 when I multiplied length times width. But what about the formula for area of a trapezoid? Well, I know that the area of a trapezoid is 1/2 height base 1 plus base 2. And remember, the bases are parallel to each other. So here's base 1, and this is base 2. This is my height. And my height, if this whole side is 35 and this is 25, my height is 10. So 1/2, 10, 10 plus 15, which is 5 times 25, or 125. So the total area, 375 plus 125, is 500, but that's not our answer. That's only the area of this shape. If we want to find the volume of this bucket, we need to multiply that area by the length of 40. So 500 times 40 gives me 20,000, or choice C. Pay attention because look, 500 is choice A. They expect a lot of people not to read the question closely and go with that 500. That 500 is close, but wrong because it's not the volume of the shovel, but instead the area of the side of the shovel. Okay, let's take a look at 18. 18. Point C is the center, D is 37 degrees. This is a radius, this is 15, and this is 37 degrees. Which of the following expresses the length of the radius? Well, that's using opposite and hypotenuse in this right triangle, and I know sine of theta is opposite over hypotenuse. So the sine of 37 equals radius over 15. And they asked me to find radius, so I need to multiply both sides by 15. There's the radius. And that corresponds with choice G. G for 18. What about 19? Well, we're told that theta is some angle between 0 and 90 degrees. So I'm going to draw a triangle in first quadrant with a theta. And it says cosine of this is 5 root 2 over 8. Well, I don't really care how big theta is. But I do know that cosine is adjacent over hypotenuse. So I could make this 5 root 2 and this 8. Now they do ask me in this problem to find tangent theta. And tangent uses opposite and adjacent. Well, I already know that the adjacent side is 5 root 2. What about the opposite side? I need to find that. And I can use the Pythagorean theorem to do that. I'll know that 8 squared equals question mark squared plus 5 root 2 squared. Remember, 8 is the hypotenuse. It has to be by itself. It's not 8 squared plus 5 root 2 equals question mark squared. It's, in fact, the two shorter ones squared get added together to equal the longer one squared. So I get 64 equals 25 times 2, or 50, plus question mark squared. 14 equals question mark squared. And so when I take the square root of both sides, I get the square root of 14 is the opposite side. And since tangent is opposite over adjacent, we know that the tangent of theta must be that opposite side over the adjacent side, 5 root 2. Now when I look at my choices, I don't see this choice, but I do recognize that the square root of 14 could be written as the square root of 7 times the square root of 2 over 5 times the square root of 2. These square root of 2's can cancel, giving me root 7 over 5, which is choice B. B for number 19. And halfway through the On Your Own, problem number 20, what can we say here? Well, the table is given several points. Parabola passes. One of the x-intercepts for the graph is given. What's the other x-intercept? Well, when I look at this table, I notice, I don't really want to draw the whole table again. I notice here, see, I said this was the vertex. Now, how did I know it was the vertex? Well, I see the points getting lower and lower and lower, and then they start going up again. And I notice that the distance from here to here is the same as the distance from here to here. And because of that line of symmetry around the axis of symmetry, I know that this point must be my lowest point. Well, from one x-intercept to that axis of symmetry, the distance goes from 2 to 5, or is a distance of 3. So from that axis of symmetry at x equals 5, if I go another 3, I'll hit another x-intercept. So 5 plus 3 will bring me to 8. And so 8, 0, or h, is going to be my other x-intercept. Okay, how about 21? 21, we've got ordered pair A is located at root 2, 4, and B is located at 6, negative root 3, and C is collinear. Oh, B is the midpoint. Oh, okay, and I'm looking for a point C. And I need the x and y coordinates. Oh, approximate x and y coordinates. All right, well, let's think about this. How far is it from root 2 to 6? Well, if this number were 2 and this number were 6, the distance would be 4, we would say, or we would say this minus that. So this minus this is this distance, 6 minus root 2. So this distance must also be 6 minus root 2. And I'm adding that to the x value I already have. So 6 plus 6 minus root 2, or 12 minus root 2. 12 minus root 2 is about 10.59 on my calculator. But I've got two choices that could work. One of them is D, and one of them is E. One has a positive y value, one has a negative y value. I know that I started in positive land. I went negative. So this has to be even more negative because I'm only gone to the middle and now I have to go to the other end. So I'm going with choice D here. But just to be sure, remember what we said. The distance would be this minus this. So this minus this. This is negative 3 minus 4. And that means from here, I'm going to go negative root 3 minus 4 again. So negative root 3 is where I was, plus a negative root 3 minus 4. And I'll end up at negative 2 root 3 minus 4. And when I get a decimal approximation of this, I end up with negative 7.46. So choice D for number 21. 22. Ooh, 22 is going to take up a bunch of space because it's a big distance formula problem. We're given two ordered pairs for number 22. One of them is A2 and the other one is 16A, and we're told that the distance between those points is 10. So if I use my distance formula, 10 equals the square root of A minus 16 squared plus 2 minus A squared. Oops. Right, because x sub 1 minus x sub 2 squared, y sub 1 minus y sub 2 squared. I'm going to get rid of the square root by squaring both sides. And so I'll have 100 equals a minus 16 squared plus 2 minus a squared. Now I've got some foiling to do. 100 equals a squared minus 32a plus 256. Plus here we'll have 4 minus 4a plus a squared. When I combine like terms, I get 100 equals 2a squared minus 36a plus 260. And I'm going to subtract 100 from both sides. 2a squared minus 36a plus 160. And now I'm going to factor a 2 out to make my factoring a little easier. And the factors of 80 that add up to negative 18 would be negative 10 and negative 8. So we get a equals 8 and a equals 10. So when I look at my options here, 8 is not a choice. Negative 8 is, but that doesn't work for me. I've got 10 here, and that's choice F for number 22. 23. Bob and his wife Linda leave the house at 7:30 and commute to work. Bob drives 60 miles an hour, goes north for half an hour. So 60 miles an hour for half an hour, he goes half of 60 miles or 30 miles north. And then he drives for an hour east. So he drives 60 this way. Okay, so Bob is located at 60:30. Now, what about Linda? Linda drives 50 miles an hour, goes east for an hour, so she's here at 50, and then she goes north for half an hour, so this would be 25. So Linda is located at 50:25. Okay, and what are we asked? In which following expression represents the number of miles apart they are at 9 a.m. when they arrive at work? Well, to me it sounds like I want to use the distance formula between Linda's point here at 50:25 and Bob's point here at 60:30. So remember, the distance formula would look like square root of this x minus this x, 60 minus 50 squared, plus this minus this, 30 minus 25 squared. And when I look at the choices here, I don't see any that have 30 minus 25, but I do see 25 minus 30, and that would give me negative 5, but when I square it, I would get the same positive 25 that we'll get here. So I like choice B. Choice B represents the distance between Bob and Linda. Okay, number 24. 24. What's the greatest number of points of intersection between a parabola and a circle? Well, if I think about a circle and I think about a parabola, I can imagine 4 points of intersection. I guess I could certainly imagine 3 or even 2, but they said the maximum number of points, and to me it looks like I can't get more than 4 points of intersection, which corresponds to choice J. Choice J for number 24. 25. 25, we're given that there are these 2 points, negative A and B, and the distance between them is 10. So, and we know that one of them is a negative number, the other is a positive number. Which could be the factored form of the equation of the parabola? Well, remember, parabola in intercept form is x minus a, x minus b. And here, we're plugging in a negative, so x minus a minus a, x minus b. I would expect to see x plus some number and x minus some number. Now, I do see that in choices B and D. So, which is mine? Well, notice the 2 choices. One is x minus 7, x plus 3, and the other is x plus 10 and x minus 1. Well, what's the distance between these points? From negative 7 to 3 is 3 minus a negative 7, or 10. Whereas here, I have negative 10 and 1. 1 minus a minus 10 is 11. We were told the distance between the 2 points had to be 10, so this can't be my answer. This has to be my answer, and that corresponds with choice B. Choice B for number 25. Okay, 26. Let me just say this. If you don't know what an ellipse is, skip this problem. If you don't remember the formula for ellipse, skip this problem. Now, having said that, I'll go through this problem. 26. X minus 3 squared over 16 plus y plus 2 squared over 25 equals 1. What I remember about an ellipse is this is the center, 3, negative 2. This tells me how far from that I go left and right, and this tells me how far from that I go up and down. Oh, but wait, these are squareds. So really I'm going to go left and right 4 and up and down 5. So if I were to plot 3, negative 2, I would go here and here, over 4, over 4. So this would be negative 1, negative 2, and this would be 7, negative 2. And I would go up 5 and down 5. So I am at negative 2, and I want to go down 5. I'll be 3, negative 7, and up 5, 3, 3. So there's my ellipse. Now they asked me, what's the equation of the biggest circle that I can fit in here? Well, this is 5, but I can't fit a circle with a radius of 5 in there. The biggest I could get would be here. And we said that this distance was 4 and 4. So the radius of our circle is 4, and the center of our circle would be 3, negative 2. So if we go to that equation for circle, we know it's x minus h squared plus y minus k squared equals radius squared. Or x minus 3 squared plus y minus a minus 2, y plus 2 squared. And the radius is 4, so 4 squared is 16. X minus 3 squared, y plus 2 squared equals 16. That's choice H. That was number 26. 27. Let's take a look at 27. There's a triangle PQR with sides A, B, and C shown, the dotted line. D originates at P, is perpendicular. So this looks like that geometric mean thing that we talked about for a while in geometry class, which means in my brain I've got a bunch of similar triangles here. Okay, here's A, D, C, and B. And they say, what is the ratio of the length of D to the length of PQ? PQ is this length. So D to PQ, D to A. Okay, so if I'm thinking about D to A, D is the long leg, A is the hypotenuse. Long leg to hypotenuse. Well, I see this similar triangle over here, similar to this small triangle, and its long leg is C, and its hypotenuse is B. So D is to A as C is to B. C is to B. I see B is to C. Hold on a second. D is to A. What is the ratio of the length of D to the length of A? A is the hypotenuse. A is the hypotenuse. D is the long leg to hypotenuse. C over B. Huh. That's interesting. T over A. Huh. I'm sort of confused as to why this would be. Have I drawn it wrong? No, there's a right angle there. This is the long leg. This must be the hypotenuse. What about in my original small triangle? This is the long leg. This is the hypotenuse. So long leg to hypotenuse will be long leg to hypotenuse. You know, I don't see my answer here, but I'm going with the only one that's close to this. I'm going with B and a question mark. All right, we'll have to think about that. 28. The area of a square to be tripled, the new side lengths must be the old side lengths multiplied by what number? So area tripled, area of a square. Well, I know the area of a square is side squared. And if I want to triple this area 3 times, then I'd be tripling this. And if I want to know what the side length is, I know that the side length is the square root of area. So I have to take the square root here, and I get root 3 times s. The original side length times root 3 will triple the area of the square. And that's why F is my answer to 28. 29. A certain rectangle is x plus 3 long and x plus 7 wide. if a square of side length x is removed, what's the remaining area? Well, that's the area of the big rectangle, length times width, minus the area of the square. X squared plus 3x plus 7x plus 21 minus x squared. Well, the x squareds cancel, and I get 10x plus 21, and that corresponds to choice D. 30. 30 comes with this big trapezoid. I know it's an isosceles trapezoid because they show me that both of these legs are the same. This is 8, and if I drop these heights in, I know the height is 3 here, so the height over here is also 3. This length of 8 would be this, but how long is this? Well, look, it's a 3-something 5 right triangle. You know, I hope you recognize your Pythagorean triples. It'll save a lot of time. But if not, I could always do 5 squared equals question mark squared plus 3 squared, and get 25 equals 9 plus question mark squared, or 16 equals question mark squared. And when I take the square root of both sides, question mark equals 4. So I know that these are each 4. So this whole side length then is 8 plus 4 plus 4, or 16. The area formula for a trapezoid, remember, is 1/2 height, base 1 plus base 2. In this problem, our height is 3, base 1 is 8, and base 2 is 16. So I have 1/2 times 3 times 24, or 12 times 3 for 36. That's choice K. K for number 30. Okay, 10 more problems to go. We'll be all set. 31. So here we're told that we can approximate the area of this sector by using, or the area of the shaded portion, this segment, by using this formula 2ch over 3 plus h to the third over 2c. Yeah, I've never seen that formula before. It's kind of cool. I'd like to know where it comes from. But all I'm going to do is plug in my h value of 2 and the chord length value of 6 and see what I get. 2 times 6 times 2 over 3 plus 2 to the third over 2 times 6. So I get 24 over 3, which is 8. 2 to the third is 8 over 12. I guess I can do some reducing here. This would be 2/3, 8 and 2/3. And that's choice D. 32. Nine, 40 degrees, A, B. Okay, how long is this minor arc? Well, we did an arc length problem before, and we said S equals R theta if you know trig, but you have to turn that 40 degrees into radians, so you might as well think about this problem the geometry way and say that arc length is going to be 40 over 360, what part of the whole circumference? 2 pi times 9. Well, I can do some canceling here. This 9 here, 9 goes into 9 once, and 9 goes into 360 40 times, and then the 40s cancel, and we end up with 2 pi. And that's choice G. Choice G for number 32. Okay, how about 33? Oh, that one we should be able to do. 33 is just the volume of a box. We know the volume is length times width times height. What is the volume of the solid? Oh, well, maybe this is going to be a little more work because they didn't give me the side lengths, they gave me the areas. This is 28, this is 20, and this is 35. Okay, so this number is a factor of both this and this. And I can see that what number goes into both 35 and 28? 7. And this number is a factor of 35 and 20. What number goes into both 20 and 35? 5. And this has got to be a factor of this number and this number. What number goes into both 28 and 20? 4. So my volume is 7 times 4 times 5, or 20 times 7, 140 cubic centimeters, and that's choice B. Okay, 34. We've got a cube, and we're drawing a sphere tangent to that cube. Okay, and what do we know? With a radius of 3. Well, so when I think about this sphere with a radius of 3, this would also be 3, and therefore the side length of my cube would have to be 6. So the side length of the cube is 6. The volume of the outside contained outside and inside. Okay, so I'm looking for this volume here, which is the volume of the cube minus the sphere. Well, the cube has side lengths of 6, and the volume of a cube is side cubed, or 6 to the third, or 216. Now, what about the volume of the sphere? Well, they didn't give it to me, which means I'm supposed to know 4/3 pi r cubed. Remember, the radius of the sphere was only 3. So I'm going to have 6 to the third minus 4/3 pi 3 cubed. Tink, tink. I get 36 pi here and 216 here. And when I do a decimal approximation with my calculator, choice G is the best fit. Okay, problem 35. A rectangular box with an open top is constructed from cardboard to have a square base with area of x squared and a height of h. If the volume of this box is 50, how many square units are needed to build the box? Well, I know that the volume of the box is length times width times height, or x squared h. I know the volume is 50, and so if I divide both sides by x squared, I can get h. H is 50 over x squared. And why did I need that? Well, if I think about the open-topped box, so it's got a bottom, and it's got a side, and another side, and another side, and these are the sides of the box. Now, I know that this is x by x, and all of these sides have a height of h for height of the box. So what's the surface area of this box going to be? Well, I have 4 of these sides, and they're x times h, and I have this bottom here, which is a square plus x squared. But I notice none of my choices have h's in them, and conveniently I know that h is 50 over x squared. So down here where I see h, I have to replace with 50 over x squared. 4x times 50 over x squared plus x squared. I can cancel an x, and I get 200 over x plus x squared, and that corresponds to choice C. C for number 35. Okay, let's take a look at 36. Radius of a right circular cone is 1/5 the radius of this other right circular cone, and the height is 1/4 of the height of the other one. Well, I need to know that the volume of a cone is 1/3 pi r squared h to do this problem. And I know that one of the radii is 1/5 the radius of the other, and the height is 1/4 the height of the other. So this is the volume of B, and this would be the volume of cone A. Well, let's figure out the relationship between them. I'm going to square the 1/5. 1/25 r squared times 1/4 h. And I'm going to multiply these together. And have 1 over 100. Now, why don't I multiply the 1/3 as well? Well, look, I'm comparing this volume with this volume. And this volume has the 1/3, has the pi, has the r squared, has the h. They're 1/100. The volume of A is 1/100th of volume of B. And that corresponds with choice K. 37. Earth makes a complete rotation every 24 hours. Through how many degrees does Quito on the equator rotate from noon on January 1st to 3 p.m. on January 2nd? Well, noon on January 1st to noon on January 2nd is 24 hours, and 3 p.m. is 3 more hours, so I'm going a total of 27 hours. Okay, and how many degrees would that be? Well, we know in 24 hours, we're going to do 360 degrees. So in 27 hours, how many degrees will we go through? And so I can solve this proportion by multiplying both sides by d and getting d times 24 over 360 equals 27. I notice that 12 goes into both of these, 30 and 2. Oh, look, I can take this even further, 1 and 15. If I multiply both sides by 15, I get that d equals 27 times 15, or 405 degrees, which is choice D. 38. 38 says sine of theta is root 11 over 2 root 3, and that theta is in the first quadrant. So sine is opposite over hypotenuse, and I don't know what that side is. But they asked me to find the cosine of theta, and cosine is adjacent over hypotenuse. So I'm going to need to find that missing side length, and again I'm going to use Pythagorean theorem because I've got a right triangle here. A squared plus b squared equals c squared. So I get question mark squared equal plus 11 equals 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. Question mark squared equals 1, and when I take the square root of both sides, I get 1. So I know that question mark equals 1. Okay, what's the cosine in this picture? Cosine in the... Ooh, this is problem 39. We have to go back and do 38. Cosine in this picture is adjacent over hypotenuse, 1 over 2 root 3, and that corresponds to choice A. Let's go back and do 38. 38 says Elizabeth wants to determine the height of a flagpole. She stands 100 feet from the base, measures the elevation to be 40 degrees, and she wants to know the height. Well, which trig ratio can we use here? We know we want to find the opposite side, and we're given the adjacent side. Which trig ratio uses opposite and adjacent? Tangent uses opposite and adjacent. So we're going to say the tangent of 40 equals h over 100. And if I multiply both sides by 100, I can get h by itself. The problem tells me that the tangent of 40 is 0.839 times 100, or 83.9. It's approximately 84, and so I'm going with choice K. Okay, our last problem, number 40. Number 40 uses the law of sines. Sine A over A equals sine B over B. And I'm going to say sine C over C. I notice that I need an angle-side pair in order to use the law of sines. I know that this is 35 degrees, but I don't know that. I know this is 45 degrees, and I do know that. So I'm going to do sine of 45 over 7 equals, but wait a minute, I'm supposed to find this, and that's across from this angle. Well, how big is that angle? I've got 35, I've got 45, that's a total of 80. The triangle has 180, so this must be 100 degrees. Sine of 100 over z. It'd like me to solve this equation for z, so if I multiply both sides by z, and then multiply here by the reciprocal, or multiply by 7 and divide by sine 45, multiply by 7 and divide by sine 45, I can get z by itself. Z equals 7 sine 100 over sine 45. And that seems to be choice K. I hope it was helpful going through this packet. If you have any questions, please don't hesitate to ask. Okay, take care.